Today we're going to talk about an interesting topic. We're at this web server conference, and I'm going to touch a topic on serverless. My name is Dragos. I work for Adobe I/O. I'm a project lead there. I've been at every single NGINX conference so far. It's been a pleasure working with NGINX, and actually part of the success that we have in Adobe is due to their awesome server, the performance that it brings, and it's all very cool. I'm super excited to be here. You may be wondering, let me just put this somewhere. Okay. You may be wondering, why are we talking about serverless? Why is it so important that we should care about? And what role does NGINX play in this picture? So I'm prepared to cover these two questions and also to show you a few live examples. I've actually prepared 3 demos. I hope at least one of those will work fine. So why serverless? I will bring 3 reasons that I noticed why serverless came into the picture, and they are mostly coming from the experience that I have at Adobe. You see, a while ago, if you can still remember, we were building these big desktop applications, and we have the monoliths on the back end, and the entire user experience was pretty much inside of that computer screen. And in many cases, even the data was there, unless you were in a corporation and you had a shared storage and put data there. Then mobile applications came into the picture, and they started to port some of the desktop capabilities into the mobile screens. And it also made sense in the back end to split the monoliths into simple microservices. I think starting with this year, especially, we're experiencing something new, and I think that's primarily driven by voice. Now, voice is taking us even away from mobile in a more natural user experience. And probably it's not just voice. Probably voice, along with AR and VR, are going to dominate the next user experience that we're going to face. So a particular thing about voice, if you think about, is that the interactions are shorter. You can ask a question, get an answer back, and then quickly switch the context, maybe ask a different question, send a text message to somebody, then check the weather, and then the interaction closes. We could also imagine a hotel room that has a voice-enabled personal digital assistant with which we can interact and ask questions about local movies, local restaurants, make a reservation, play music, not take photos. That would be nice if it would be, what is the Amazon show, I believe? No, it's not this show. I forgot the name. I forgot the product. So if we have a digital assistant and with voice we can quickly switch the context, then the question is, how do the microservices in the back look like, right? And I guess the point that I'm trying to make is that the interactions are more diverse, and so the microservices in the back have to be the same. But not all interactions happen in real time. Like imagine us being somewhere in a nice location, we're taking pictures with the phone. The pictures are asynchronously copied into the cloud. And once they're in the cloud, an event is triggered. Then, in response to that event, a series of microservices start processing the picture. We could imagine that it could do a face recognition in the picture, see where the location of the picture was, see if there's any other similar pictures taken in the same place. And with AI in the background, build these stories for us. Serverless comes with an offer here. Like we don't know, the nature of the events is that we don't know when they're going to happen. So serverless comes with a promise here And it says basically that when the event is happening, I'm going to invoke the code, and you don't have to worry to scale a series of microservices. Another interesting factor to my example with the photos is that if we are to process and to build such a system, it's common to see a few components in it. It's common to see a queue in which we put all the events, and then a microservice that consumes from that queue. And then this microservice could orchestrate other microservices, and each microservice is responsible for a single thing, like auto tag people, one microservice, another microservice identify location of the picture, and so on. I wanted to keep this in mind as we're going to go into serverless. So besides user experiences, the second driving factor is cost and operations optimization. And we're probably familiar with the fact that it doesn't take so long nowadays to spin up a virtual machine, but in the older times, it would take a lot of time to schedule for the bare metal boxes to be bought and be installed and so forth, configured, network, routers, and so forth. Right now, we expect that we go to a public cloud provider and provision a virtual machine within seconds to minutes, I would say. And then containers came into the picture, and containers run in VMs, but they promise to just start faster, and they're easier to be deployed. With serverless, we're just taking this a step forward. We're looking at functions. We're looking at functions, and we believe that functions are easier to start. And it's funny how things build up. You know, we have VMs that run in bare metal. We have containers that run in VMs. And now we have functions that run in containers. And the time to spin up this logic is shorter and shorter and shorter. Serverless should be able to spin up a new function within milliseconds, maybe in 2 digits. Right now, not all platforms achieve this performance, but I think every single platform marches towards this goal. But containers themselves wouldn't complete the picture if we didn't have container orchestrations. And technologies such as Mesos or Kubernetes make it even easier to spin up containers in a supercomputer in the cloud. If you're not familiar with Mesos or Kubernetes, they both provide like a nice API over the whole data center. And the data center, through that API, looks as if you have a supercomputer with hundreds, if not thousands, of CPUs and terabytes of memory. So it's quite fun to just not having to think of the VMs, but thinking of how many instances of my container I need to support my traffic, and then worry about how do I scale that. So serverless is simply a step forward. Instead of thinking of the containers, we want to think of the code. The last interesting point that I want to capture related to cost and operations optimizations is that when we think of serverless, the scaling unit is a function. The function is smaller. So the odds of improving resource utilization in a data center on the premise that we have smaller units of scale that are only executed when they're needed are bigger, because running the code only when it's needed, then it means the code and the containers that run, that the functions are deployed into, they will only be executed when it's needed. And if they run, it means that they actually do something. So besides user experience and cost and operations optimizations, I would mention the third driving factor is product extensibility. Probably we don't hear a lot of when we hear people talking about serverless, about extensibility. But for instance, for us in Adobe, it does matter a lot, because in Adobe, we're not thinking it to be yet another general purpose serverless infrastructure. But the reason why we're looking at serverless is that we believe we can make powerful experiences around existing Adobe clouds, so that if you have already content stored in Adobe or data stored in Adobe, but something is missing, or you want to integrate that content with another system, then Adobe is providing you an opportunity to write the code. Adobe is going to run the code, and you can extend very easily the products and services that you purchase from Adobe without any other investment on your side. Without this, so without serverless, any extension would be a burden for the developer in regards to running the code somewhere, etc., etc. So serverless promised to also bring this capability. So with serverless, and actually with the, I want to make this statement that modern apps have a richer user experience. As you saw, they have become smaller, are composable, and through the events, they're also more real-time. I want to show you a sample of how we can extend Adobe service. So I picked Adobe Analytics. I'm going to show a sample. If Alexa will be nice to me, I have Alexa on my phone right here. So I have Alexa speaking through the Adobe I/O runtime where the code runs with Adobe Analytics, and the only thing that I want to do is, instead of browsing through the Analytics API and UI, browsing through the UI, I just want to use my voice to get some information out. And I want to show you such an experience. Let me bring the volume up, and I hope I only have 4G. It's not LTE. All right, let's see. Alexa, ask Adobe Analytics. No.
Welcome to Adobe Analytics. Which report suite would you like to use? Summit Demo 2017, Template Report Suite.
Demo.
Okay, using the Summit Demo 2017 Report Suite. How can I help you?
Tell me how many visitors last week.
The total number of visitors last week was 5,113.
What's the bounce rate last week? Bounce rate. I think it's going to error out. Sometimes when I ask Alexa about bounce rate, she would say balance rate, and that doesn't translate to anything. It just happened to me before the demo. It's still loading. Or it's just my 4G. Yeah. So this is just a simple way to show you that you could even interact with the complex products such as Adobe Analytics and ask questions and use your voice to actually get data out. And this is really just tapping the surface of what's possible, because we can imagine these agents being more intelligent and actually going in the background and crunching data and give us more intelligent responses back. But even so, this is cool, and it's very easy to implement with these technologies. Before we move ahead, I don't want to confuse, and I wanted to clarify the difference between backend as a service and function as a service, because people speak about these two and they put them in the same category with serverless. It's actually a very simple difference between it. With backend as a service, we're thinking at services that are running in the cloud, like databases or storage. It could be DynamoDB, Cosmos DB in Azure. It could be S3 in Amazon. It could be Data Lake. These are stateful things that run as a service in the cloud that our functions interact with. But somehow, serverless categorizes both of these into the same box. But for the scope of my presentation, when I'm talking about serverless, I'm going to refer to mainly function as a service, which is FAAS. So what role would NGINX play in this picture? Well, first of all, the way that we're using it right now is to extend existing long-running services with serverless, and we build a nice API facade So even today, when somebody is consuming some Adobe APIs, those endpoints, some of those endpoints would point in the back end to serverless functions. But as an API consumer, you have no clue, no idea about that. What I noticed is that usually when a service just starts, and it doesn't make sense to have a full-blown scale, multi-region, and so forth, and you don't know whether it's actually going to be used, it's very comfortable to write a serverless action and just deploy that new API in that manner. And if it's getting used, then you can think about deploying as a long-running service. But I've also seen some versions of the API that are going to be sunset. And again, it's not worth it to run a full-blown, long-running service. So they're ported into serverless functions, and they're being kept there. I don't recall, actually, I may be wrong, but I personally don't recall actually once the services are moved into serverless, if we ever deprecate that. Probably it's not, it's used very random right now. So besides building an API facade, NGINX plays the role of a function router. I'm going to demo a little later right now how to route functions into Amazon Lambda, but also into Apache OpenWhisk, an open source serverless platform. Then once we're able to surface the APIs there, we get some features almost for granted, for free from NGINX. One of it is caching. NGINX does caching very nice. Another one is, since all the traffic goes through NGINX, that's the point we can capture the usage data. That's how we track, that's how we get the metrics of the whole API traffic in Adobe, by extracting that from NGINX. Traffic shaping, throttling, rate limiting, right? Features that we should be used with. WAF. Request validation. We also do this. All right. So let's look at some demos now. If you want to follow my demos, just remember function-router, and it's on Bitly. It's the link. Let me go there right now. All right. I think it's right here. So if you go on that link, can you see well all the way in the? Can you read all the way in the back, or do you want me to zoom? Okay, I heard a yes. Zoom. All right, I'll zoom. Let's see how it looks. I zoomed it to 175. So I have two examples here. The first example, I said we're going to deploy a function in Amazon Lambda, and then we're going to configure it in NGINX. So NGINX is going to become a function router and is going to invoke directly this action. The way it works is that at Adobe, we wrote this mini Lua SDK for Amazon years ago, like 3 years ago. We did this initially because we needed to invoke KMS and SNS, and then later we add Kinesis and Lambda. So you can find the links to the repo, to the Lua module. Let me bring it on the screen. I have it here. It's a Bitly again. It's NGINX-AWS if you want to look for that code. All right. So now I'm going back to my sample. What I'm going to do is I have a simple hello world function, which is here. It's in JavaScript. It does nothing than print saying hello, name, and from a location. Then I wrapped this function into a simple handler for AWS. This is just the semantics of writing a function in AWS. You have to export a handler, and you receive an event, a context, and a callback. And if you invoke the callback, the first argument is an error. If it's not an error, then the second argument is the successful response. So I'm going to get this function. I'm going to create an Amazon Lambda function from it. Let me copy, I think. I can get all this. So I'm going to go in AWS UI and see the list of functions. OK, I'll try to zoom in. I don't know how this interface is going to behave. Is it better now? So I'm going to create this function, authoring it from scratch. I will not be configuring any trigger because NGINX is actually my trigger. It's my function router. I'm going to give it a name. NGINX, oops. NGINX demo live. A description. The runtime is going to be Node.js 6. The function code, I'm pasting it here from GitHub. In Amazon, we also have to give a Lambda function a role, and the role specifies which resources can be accessed. And I have created a simple Lambda role that doesn't have access to any resource because it's just returning a static text, this function. But you can configure access to any Amazon service that you want this function to access. Then memory, timeout if you want to run in a VPC in Amazon. No, I'm good with the defaults. And I'm creating the function. I'm going to try to make this screen then larger, like this. All right. So once the function is created, I can go ahead and test it. And Amazon is providing me with a UI to enter the payload or the event that I want to test. So my function was expecting two parameters. One is, I'm going to say the name NGINX, and I'm going to say place Portland. All right. Save and test. And now I get the execution. It succeeded. It returned this payload. Now, I'm going to expose it as an API through NGINX. So this is my function. I will also need to get the Amazon resource name for this function, NGINX demo live. So in the repository with the examples in GitHub, there is, so we have the hello world.js. And I have configured an NGINX configuration file, which extends a microservice. So I have an upstream as a microservice. I run this in Docker Compose, and the server is aliased. I'm listening on port 80 on localhost, and I have two endpoints. The first one, the first location, API hello, is going to invoke this Lambda function, while the other endpoint, which starts also with /API, is going to go to my microservice. So in this way, I'm extending a long-running service with a serverless action. To invoke the serverless action, there is a Lua code. Let me show you the Lua code. All right, this is it. It grabs it actually requires and imports the Lambda service. It configures the Lambda service with some basic Amazon credentials. For this demo is good enough. We never use this in production. We would use IAM or STS. But just to get started, it's easy to get started with some basic credentials. So access key and secret key. I convert then query parameters into event payloads, because invoking a Lambda function in Amazon requires a POST request. But in this case, I want to have a GET request. And then I invoke the function. And I invoke it. I provide the service name, the payload. Amazon allows also for sending a context. And we use this context for instance, to send user identity. Like if the API, if NGINX validates an OAuth token, we extract from the token the user ID and some other user information, and we can send that through to the function. In this way, the function has fewer things to worry about. And in the end, from Lua, we're going to return exactly one-to-one of what the function has returned. There is also an implicit assumption that I made for the demo that my function is going to return an application/JSON. So I did it here. But like being code and being Lua, we can do whatever we want with the Lua code if this is really a problem and the function returns multiple types. You can code that in Lua as well. All right, so let's see this in action. So if you check out this repository with API Gateway example, by the way, this is called API Gateway examples because the version of NGINX that I'm using is the API Gateway that we use in Adobe. So it was very handy for me. Why? Because that gateway has the Lua module, has the Amazon SDK, and everything is in place there. So I'm going to go ahead, and there is. Let me make this bigger. In the root of this repository, I made a simple make AWS Lambda. What this does is it starts a Docker Compose, eventually, with a simple microservice that echoes something back. It also starts Redis. Redis is used for caching by the gateway. And then the third thing is the actual API gateway. And before starting this, it also configures an environment variable with the function name. And I forgot to set the function name. So I have to stop this and set the function name. I hope it will start. I could have also hard-coded the function name inside my configuration file, but then it would have been harder for someone else just to get the code and do it. So I have to export AWS function, and I'm going to copy the resource name from the newly created function. OK, it's NGINX demo live. I'm putting it here. And now I'm going to start again the whole thing. Go live. OK, and the microservice is starting. And now let's play with the endpoints. Oh, I'm going to go here, and I'm going to issue a curl on localhost /API/hello, and I'm going to provide these parameters. And if I did that, OK. It looks like I did everything right. And we got the response back from a Lambda function. And it's actually, response time is quite good. Let's see, it's 200 milliseconds real from my machine, given the network and stuff. It's pretty consistent. In Amazon, once a function is warmed up, meaning there's a container deployed with the code inside, it should be faster. But the user experience, well, now, this depends on a case by case. But if this latency is OK, then you can compose a microservice. And now, I also have, within the same configuration file, I'm also exposing a microservice that is started with my Docker Compose. I'm going to invoke that one. So that one is API. It's just echoing headers back. I can just add a header. NGINX is cool. Yeah, I missed an. Anyways, so within the same, I guess you got the point, right? If I wouldn't have shown you that a part of my API goes to Lambda, you probably wouldn't have even noticed this. So a simple way to make out of NGINX a function router. But NGINX is open source, and I also want to show you something that you can do with open source. Like if you run NGINX, Are there solutions out there that are open source that give us a serverless environment? And the answer is yes. And I'm going to speak a little bit about Apache OpenWhisk. Are you familiar with Apache OpenWhisk? OK, cool. So I'm telling something new. It's a very cool project started by IBM. In last year, Adobe joined Apache OpenWhisk. Back then, it wasn't even in Apache. And with Adobe and IBM, this project moved into Apache Software Foundation. And this year, Red Hat also joined. So right now, we have IBM, Adobe, and Red Hat contributing to OpenWhisk. So OpenWhisk is an open source serverless that you can deploy, and you can have your own serverless flavor. I mentioned in the beginning, why would you do that? You would do that if you want to add some extensibility to a platform, or if you just want to be cloud independent and run functions. It's interesting that in my example, if you check out the repo, I kept the function above the wrapper needed for Amazon Lambda, because I think we could still write functions in a way that they could be deployed independently. Like we could deploy them in Lambda or in Azure or maybe in OpenWhisk. But there are these tricky parts where in Amazon you may invoke a service. And of course, if you're in Amazon boundaries, it's easier to just go with IAM credentials and invoke that service, which is, it wouldn't be so easy if you transfer the same code into a different cloud. But for some other types of applications, it makes it interesting. So how does OpenWhisk work? Let me just give you a slide, a simple slide, which is like a 101. This is how the traffic goes in OpenWhisk. It starts with NGINX that gets the request. The request is then sent to an OpenWhisk controller that places the message into a Kafka queue. Then invokers are agents that run a single virtual machine, and they consume messages from the Kafka queue and start Docker containers, then push the code in the Docker container. That's called a cold start, and then invoke the function, and then put the response back via Kafka into a document DB. I'm sorry, to a document DB, which so happens to be CouchDB. This is, in a way, very similar architecture with the example that I brought earlier about the photos. When you take photos and the events are triggered in the cloud, and those events end up in a queue, and in Amazon there would be SNS. In older days, it could also, now more recently, it could be Kinesis, and then workers that consume from that queue, right? So all this logic right now is pushed down into a system that can do this for you. And queuing is great, especially for events. But if you use this for APIs, you're not so sure on the response time. So we're also working to have a more direct invocation path that will just bypass Kafka, and that would only be for HTTP API calls, where you know for sure that the client is waiting to get the response back. It's not going to go through Kafka. So let me show you this in action. It looks like a complex system, but with Docker Compose, you can run this locally. Let me show you how, if you want to do this, where you can get the repo from. So I'm going to switch the screen. Now I'm in OpenWhisk. So github.com/Apache, there is an incubator OpenWhisk DevTools repo. And inside of this repository, there is a Docker Compose. It's also a makefile. So if you execute, let me make this bigger. If you execute something like make quick start, it will spin up Kafka, OpenWhisk ecosystem, and NGINX as well. I did this previously so that we don't have to wait too long. And I'm only going to do now make run. OK, port 80 is taken by, OK, I need to stop the previous example, which I'm going to do right now. Come on, Docker, faster. All right, good. Now let me go back to make run. Yeah. So I'm just going to give it a little bit of time for everything to be created. And if I go now to bit.ly function router, so that I get back to my example, I also want to show you this code while OpenWhisk is initialized. So this is inside the serverless router folder, Apache OpenWhisk. There's a README that just explains step by step exactly what I'm doing right now, how to run this locally. In this case, the hello world function looks easier. It's just the function itself. It doesn't need that wrapper that we saw in Amazon, which is nice. It's just easy, just the function main. And the configuration for NGINX is also a little bit easier. But you can imagine that because in OpenWhisk everything starts with that NGINX, right now I don't have to have any SDK on my NGINX. So what I'm doing is I have this location API/hello, which is exactly the same as the previous one. But instead of using Lua to invoke, I'm using the proxy path. And I go to the controller, to the path where my function is deployed. So it looks like everything started correctly. And now I'm going to go and create the action. Oops. All right. Whisk also comes, OpenWhisk comes with nice CLI, which is whisk action create. I'm creating NGINX demo from this hello. All right, NGINX demo has been created. And now I'm going to invoke the same function, localhost API hello is exactly the same. If everything works fine, it should return hello NGINX from Portland. Because I'm running this locally, I can also show you what's running on my machine. And what I want to show is that right here I have a Node.js 6 action, which was started by my invoker. So what happened is that the request went from NGINX into the controller, then into the Kafka queue, and then the invoker there. Invoker consumed the message. And let me show you again, invoking this locally. We get pretty instant responses back. So even though it's Kafka and it's a queue, it's working pretty nice, and it's pretty fast. OK, let me switch back. So we did the hello world function. All right. So we looked at why should we care about serverless, and we looked at the three driving factors, the user experiences, the optimizations in the cost and operations, and the extensibility. Then we saw the role that NGINX plays. And we look at some examples on how to extend a microservice with Lambda. And I will close with some of the serverless use cases where I think it makes sense for us to think of using serverless. So one is extending these long-running microservices. Just demo this. Other use case is to compose microservices. And I think we just did this. We composed a microservice from a long-running service and a serverless function. But we can also compose a microservice from multiple functions. There's teams that do, for instance, a function for each HTTP method, a function for delete, a function for put, a function for post. Another use case is invoking code in response to events. Chatbots, these are also real-time. They involve a small piece of code. And another nice use case is orchestrating workflows. Then machine learning and big data. The market doesn't really speak about these use cases right now, but I'm expecting to see machine learning being run as serverless and as well as big data. So I'll leave you with two thoughts. Build great experiences, and NGINX is awesome if you use it as a function router. Thank you very much for being here. I hope you learned something new. If you have questions, my time's out, but I will be here. I can take your questions. Thank you very much.